All right. So I have 75 minutes to go through as much of this as I possibly can. It's possible I will need to do a quick lecture in the afternoon, but that's neither here nor there. So this particular point is not a ton of code. I want to kind of give you like a background of React, where it came from, all the browser and all the history of the modern web and things like that, just so we know why React came into play and why it's going to be important for the 21st century of development. So I want to rewind 8 years. We're going to go all the way back to 2010. Back in 2010, like, what phone did you have back in 2010? Does anybody really remember? You had a BlackBerry? All right. What did you have, Danny? You remember?
Not a smartphone.
Not a smartphone. What did you have, Raymond?
Razor.
You had a Razor. Okay. I think I had one of those. Do you remember those phones that would were the touch screen and then you could flip it open like a sidekick and you could type? That's what I had back in 2010. But right around 2010, when the Blackberries were still like really popular and the first iPhones just started to come out, mobile devices started getting really, really popular. And as a result of that, people like Steve Jobs and other titans of industry, they saw a lot of people were moving much more towards mobile than they were. Like they said, this is going to change the world because phones are cheap. You can most people have more easy access to it because a computer is now $1,000 plus, and you can get a phone for $200 to $400. And that's for the first time that you saw a lot of front end frameworks, things like Angular, Backbone. Like if you've heard of those particular JavaScript libraries, but those libraries basically help developers create UIs, user interfaces, without worrying about the code that created those UIs. So including like, how do I hook up my model to my views? How do I connect my routes to my controllers? I don't need to write a ton of HTML and CSS. Those frameworks did it all for me. There's been a lot of fighting recently. There was Angular, there was Backbone, there was Ember for a long time. And there was a period of time back in 2014 or so, there was a website called Days Since the Last JavaScript Framework Came Out. And at most, it was 6 or 7 days because everyone was fighting for market share because they wanted to write the newest and greatest JavaScript library, and they wanted to last a long time. What everyone ended up settling for was not settling for. What everyone decided was the best thing was React, and that's something that's backed by Facebook. It's the latest and greatest JavaScript framework, and it's going to be around for quite a while. Like I said, you have a lot of big companies backing languages. So Oracle backs Java, Google backs Go and Python, and most financial firms and most places that are a little bit older still use C# and C++. You can generally say if a big company backs a large framework or a language, it's going to be around for a while. So React will be around for a while. You may be like most of the stuff we've been doing so far is mostly back-end code, and you might be wondering, why do we bother learning front-end development? And basically, over the last few years, we've seen a huge shift from the responsibility of most of the code being on the back end to most of the stuff being on the front end. So when we talk about the MVC model, stands for Model View Controller, most of the logic is happening on the back end. So the two of the three things, like model and controller, are happening on the back end. But the problem with this is that as there are more users and there's more people grabbing phones and more people getting on the internet, there's going to be more load on our servers. There's not enough money in the world, and there's not enough physical space in the world to keep up with a growing population of people who are using cell phones and devices like that. Because I was like, for me, I have a phone, a tablet, 2 computers, and that's just me, right? Like my wife also has a phone, a tablet, and 2 computers, like a personal one and a work machine. So it's like the 4, like I personally can use 4 things at any given time. And with that, there's more people in third world countries getting access to technology, which is a wonderful thing. But as there are more people in the world, there's not enough money and there's not enough space to like keep up with the growing population, how much stress they're going to put on your backend. So, but each person who uses the web, however, has a modern browser. So like Danny and everyone in this room have Chrome. Your Chrome browser takes a lot of bandwidth on your machine. Like it uses most of your memory. So what people are doing is saying like, all the stress should not be on me on one central location, like one server farm in Pennsylvania or something, but it should be distributed among everybody else. Your machine should be doing most of the heavy lifting. Like your Google Chrome should be doing most of the heavy lifting so that it gives you a seamless experience. So basically all of your browsers now can take care of all the routing, all the displaying of data, all of like everything that used to be all back-end heavy, your machine can now take care of on the front end, which is pretty crazy. So that's it.
How is that possible? Just the software that Chrome is using?
Exactly. Yeah. So your Chrome browser, like if your computer is really slowing down, if you ever use Firefox, you'll notice your computer slows down a lot because it uses 100% of your memory because it's the worst browser. But Google Chrome will usually use around 30 to 40% of your available memory because it's just so labor intensive. It's making all the requests in the backend, right? So it's making all your HTTP requests. It's getting all those responses back, synthesizing all of them, and then posting them up so that it looks like your normal web page. When you're writing React code, you're going to notice that you're going to load in all of the routes all at one time, and all of the data you might need all at one time. And your browser is able to hold all of that information on the front end so that it doesn't have to continuously make requests to the back. It's pretty interesting. We'll see that later this afternoon and starting tomorrow. So this is what we're going to cover today. And remember that all front-end code at the end of the day, React, Angular, Ember, Backbone, all these JavaScript frameworks, at the end of the day, it's just HTML, CSS, and JavaScript. It doesn't matter whatever anyone else says. That's all that shows up on the front end. That's all that matters when it comes to web development code. I'm going to share with you a document that's going to note all the differences between React and Rails. Looks a little something like this. Because I found that some people struggle a little bit. So it's kind of like, what's the Rails term? What's the React term? And what does it do? So I'm going to send this out to everybody. But it's kind of like Ruby gems are basically Node Package Manager. Rubocop is the same thing as ESLint. A gem file is the same thing as package JSON. And I'm just going to continue adding things onto here so that you can continue to be able to translate between React and Rails. Like I said at the very beginning, and I've started to see this in my own professional life, is you learn one thing and you learn it really well, and you'll notice that there's a ton of similarities between everything else. So we're going to be covering browser history, JavaScript and Ecmo Script, NPM, ESLint, Mocha, ES6, all that kind of stuff. But the main thing I want to cover for right now is this concept of ES6. ES6 is the largest update of JavaScript in the past 10 years. It came out in 2015. ES stands for ECMAScript. ECMAScript is the formal name for JavaScript. So basically what happens is JavaScript is in your browser, and your browser gets updated on its own schedule. So it's kind of like, hey, have you updated Google Chrome? Have you updated Firefox? The newest and latest standard is going to be ES6. Babel, on the other hand, is something that basically transpiles the JavaScript code that you write. So it's updated as of ES6 or older, so anyone can really view it. So the idea is kind of like, we'll get to this in a little bit, but the two big things were ES6 is what we're going to be using today. There's ES7 and ES8 and ES9 at this point, but ES6 was the biggest rewrite. That's the things like let and const, fat arrow functions, the binding of this to fat arrow functions. And then Babel is the other thing that you need to think of. Babel is this piece of software that basically says, like, if Danny's writing code in ES6, what's going to happen to someone who's using ES8? Or if he's writing in ES6, what's going to happen to someone using ES2? So Babel will basically translate it into like forward translate or backward translate so that everyone can use your particular bit of code. So it's important for us to have a background in the history of front-end technology. And you're going to see that it's a pretty organic evolution, and it's a pretty interesting story. But before we get into that, I want to talk about the three technologies: HTML, CSS, and JavaScript. So I actually got to meet someone who wrote this book, The Web Design for Babies. There was basically a thing called Coding for Babies. And it basically looks like this. So HTML, just so we're absolutely certain, is the structure of the web page. My job is to get things started right. My team of helpers and I build a solid foundation by turning text documents into web pages. We are like the beams of a house. A web browser reads my file and displays it as a web page. So HTML is the structure of the web. If you've ever seen a building being built from the ground up, it's the pouring of the foundation, it's the putting on of the windows and the beams and things. I don't know anything about construction, but it's the foundation to the house. Next, we have CSS. CSS is the styling. So it's like, how tall is your building? What color is your building? What material is your building? How large are your windows? Are they mirrored windows or are they not mirrored windows? So you have stylish CSS person. And basically it's, how do using a selector, a property and value, I'm going to find something on the page and give it style. And then finally you have JavaScript, which is the function of a web page. And this is what we're going to be focusing on for the next 3 weeks. So I help web pages do really cool things by making changes to HTML elements. The main things to keep track of here, I react to events that happen on the page. So like when you reach Facebook and you reach the bottom, it recognizes that you've reached the bottom. That's an event that happened on the page. Like when you click your mouse or you point at something, different things are going to happen. So let's rewind. It's 1993. And what I realized when I was like doing all this research for this particular lecture is there was a lot of stuff that happened in the early 90s when it came to web development. If you can remember back that far, like there was just a lot of stuff going on. So 1993, the internet already existed, but it was actually called the intranet. It was mostly used at very large universities to give papers back and forth and just transmit data within one particular organization. There's a person named Tim Berners-Lee. He's written the HTTP protocol, and he's already created his own browser called the World Wide Web. This is what the original web browser looked like. It was built into OS X and then was later named Nexus. This is the OG internet. Like this is, it's kind of gross. I mean, if it's black and white, what did you expect? It's 1993. All of the people that I'm about to mention, Tim Berners-Lee and all the other names, are all decamillionaires at this point. They were all pretty much they all came out of University of Illinois at Urbana-Champaign, which is 3 hours south of here. Actually, what's his face? Chris Walquist went to school with them, which was kind of an interesting thing. And they're all like decamillionaires now, so like tens of millions of dollars because they capitalized on this very, very early. This is another text-based browser named Lynx. But what you can basically see so far is that the World Wide Web, the original one, and even links like this, there's not a ton of information going on. It's just this looks like what you used to use in the library, you know, for some of us. Like I grew up in the library, you just enter the thing, it's like all green text, and you press enter, and it basically queries a database. But by far, this was the most popular browser at that particular bit of time. So you had the World Wide Web, you had Lynx, and then you had Mosaic. This was built at UIUC, which is still like the #1, #2 computer science school in the country, at the NCSA, the National Center for Supercomputing Applications. So we're here, it's 1993. Tim Berners-Lee first creates the internet, and he creates websites. So with that, he decides he needs to create the first HTML spec to basically like centralize and make standards for HTML. This is Tim Berners-Lee back in '93. He's a very cynical guy. You're going to see different quotes. So he's like, I'm an optimist about humanity in general, I suppose. Like he's a very cynical guy, as you can see. So when 1993 came along, you had the World Wide Web, you had Lynx, you had Mosaic, and as the number of web browsers was beginning to grow, it's very important to create official HTML and standards and instructions that browser vendors could reference so that end users like you could have consistent HTML experience across browsers, and you as developers could write code that's consistent. It's kind of like, think about when drones first came out back in like 10 years ago, and everyone was like, this is the stupidest thing in the world, we're never going to need to use this. But as more people decided to use drones, and as more people are using for photography and for real estate and other things like that, basically the FAA had to get involved, and they had to create regulations about like, where can you fly this? Can you record into somebody's house through a window? Can you be like a peeping Tom and things like that? So they realized this early on with HTML. They needed to create standards that everyone needed to abide by. A year later, so this is like, you'll see that these things happen very quickly in technology. It happened quickly then, and it happens quickly now. A year later, the W3C is formed. that's the thing that you guys use online all the time, the W3 schools or something like that. That resource came as a result of the WC3. The WC3 was created by TBL, Tim Berners-Lee, and it was basically a place that created web standards. So they would maintain and iterate on HTML. Still today, like that is the central warehouse for all the rules regarding around HTML, CSS, and JavaScript. Anything that you want to change, you have to go through the W3C in order to get anywhere. So basically the idea is the W3C is now the organization that's responsible for maintaining HTML, so that if Tim Berners-Lee gets run over by a bus, like someone else is still taking care of it, and it's not limited to just one person anymore. Also, at the same time, there was at the NCSA, which is the creator of Mosaic, there was this guy whose name is Mark Anderson. Mark Anderson, he in '95 decided to leave the NCSA, where he said, like, I see where the internet is going. I'm going to create something, a new company. I'm going to call it Mosaic Communications, where he aimed to create the Mosaic killer. So again, the most popular thing at the time was called Mosaic. Mark Anderson worked on Mosaic. He said, I'm going to create a new company. I'm going to create a company called Mosaic Communications, where he's going to create something that's going to crush the Mosaic browser. And so you have Mosaic 2.0. You can still visit this today by hitting home.mcom.com, but this was the Mosaic killer, which is a little bit nicer than this, but it's still very Web 1.0.
What was the purpose of Mosaic?
Mosaic was just one of the internet browsers.
Oh, okay.
Yeah, and then Mark Anderson said, I want to make some more money, so I'm going to create my own company. I'm going to call it Mosaic Communications. I'm going to create this Mosaic 2.0 and then destroy the original. But the main cool thing about Mosaic, and like if you still go to like Space Jam, like the website is still the same after all of these years, is that the navigations are within images. So if you look back all the way to Mosaic 1.0, everything is inline text. So it's like I have to click on World Wide Web, I have to click on University of Illinois, I have to click on copyright, and you can only link links within text. But the cool thing about Mosaic 2.0 was you could do navigations within images, which is something that no one could do. Again, this is all happening within like 6 months to a year. So these are like huge revelations and huge things that are happening. This was one of like the links on the page. So if you clicked on, I don't know which one, if you clicked on one of these particular things, it would get to this point. So Mosaic Communications, Mark Anderson's company, was supposed to create like a Mosaic 2.0. So they created something called Netscape. Do people remember Netscape? Like way back in the day with like the little boat turning thing, steering wheel. Basically, Mark Anderson and his company developed a commercial web browser that was paid. And he said that this one is going to beat everybody else. So it's 1993, HTML is formed. 1994, did the WC is formed. In 1995, the Netscape Navigator was formed. So within a year, they created a browser. It takes much longer than that to create an internet browser today, but they did it in less than 1 year. And the big thing to notice about what Netscape was offering was secure communications. The Netscape and NetSite bring secure communications. And at this point, you had the HTTP protocol. It was created, but it wasn't secure. So you're not able to have e-commerce because your credit card number could get stolen. So, but because Netscape was saying like, we're offering secure communications, HTTPS, they don't have to worry about like all the security flaws, and they can start to go with e-commerce. So you can kind of see Netscape, it's fast, it's reliable, consistent, and it's secure. And you can have this for the low price of $49.99. And it's a lot of money even now, but back then, like $50 was worth a lot more. Probably, I don't know, what was $50 worth back in '93? $200, $300 or something like that. It wasn't very cheap, but people were very happy to pay this because they were able to go online, they were able to place orders online, they were able to, just basically use the cutting edge technology. And with that, we came out with Netscape Navigator 2.0. around this point, you have Mosaic, you have Lynx, you have the World Wide Web, you have Netscape. Like as basically what's that?
When you paid for it, did you get the cord as well, and the modem and all that stuff?
I don't think so. I think you just got access. I think you just got the CD-ROM with like the product key to, yeah. So at this point, you have like 5 or 6 different competitors, and basically Mark Anderson says, as the internet's going to grow, we're going to have to create a browser-based programming language. Up to this point, we didn't have anything. It was all heavy back-end stuff. No one understood anything. So he said, we need to create our first browser-based programming language. Can you guess what that first browser-based programming language was? JavaScript? That's a decent answer. It's not PHP. Actually, it was an alliance with Sun and Netscape. They decided to use Java. So Netscape and Sun joined forces to make this happen, and you had Java right over here. And you remember we're going to talk about RSA security tomorrow when the presenter comes in tomorrow. But basically, Sun, the company that made Java, said that it should be the only browser-based programming language, and they really did this for job security. But they realized very soon after that it's really, really difficult to learn Java for amateurs and for beginner programmers. They needed a language that was a little bit more basic, something like Visual Basic in Microsoft Stack at the time, something simple, something casual that people could pick up and embed directly into our HTML. So what they aimed to do was provide a glue language for web designers, which are front-end engineers, and part-time programmers, back-end engineers, who are building web content from components like images and plugins and Java and stuff like that. So they had the component language, they had the back-end language, which is Java, and they needed to create the front-end one. This is an example of how you would load Java into HTML. Everything looks pretty simple. We have an HTML document, we have a head and a body. But the main thing that you have to keep track of is this little applet code right here. This was what the original like Java code would look like to get things put into place. But because Java was so difficult to learn and they didn't really know what to do with it, they had this person who worked at Netscape named Brendan Eich. He was part of the Netscape team, and he created JavaScript in, guess how long it took him to write JavaScript? The entire language from front end to back. 3 weeks? I got 3 weeks. What else?
I say 7 days.
7 days. All right. A month. It took him 10 days. 10 days, both the language and the engine behind it. So in less time that it'll take us to learn React, he actually wrote the entire language that's lasted 23 years up to this point. So at first he called it Mocha, then he called it Mocha Script because it was all like coffee-based things back in the day. And then we finally settled on JavaScript. But JavaScript was very buggy. He's the only person working on it. So it's 1995. We have, remember, 1993, HTML comes out. In 1994, W3 Schools. 1995, Netscape Navigator 1.1 comes out, with the big thing being HTTPS. And then in the same year, Netscape Navigator 2.0 comes out, where they're able to support Java and JavaScript. So in the same year, they released a huge release, and these things are happening real quick. It seems like every 6 months a new big thing is happening. Also in the same year, we have the HTML 2.0 spec coming out, and the webmasters back in the day, they're basically the web developers of the 1990s, and they basically said the original HTML specifications aren't robust enough. They need updates, and they got this 2.0 version of HTML. So I've mentioned the Mosaic, I've mentioned Netscape Navigator. What's the huge, like, 900-pound gorilla in the room in the 90s when it comes to technology? Like the company that was so huge back in the 90s. AOL, what else? Starts with an M. Microsoft. So despite being the largest operating system, you may have noticed that I haven't really mentioned Microsoft yet. But like Microsoft in the background, they're seeing all this stuff happen. They know that their platform, Windows 95, is like a huge, it was a beautiful like operating system. Everyone liked using it. And it included, but when they started seeing everything coming out, they're like, we have to create our own browser. So what they did was they created this browser, Internet Explorer, and it came pre-installed on their on all of their Windows 95. It looks like this to kind of get started. Wow, I can't believe this was actually the internet, but that's okay. So at that particular time, this is what's happening underneath the hood. We have Netscape Navigator and HTML, everything happening on the top. And on the bottom, in the same year, we have Internet Explorer version 1.0 and 2.0. Internet Explorer 1.0 and 2.0 came out, you can see, right after Netscape Navigator 1.0 and 2.0. And what that means is they basically copied all the stuff over from Netscape Navigator, and they put it inside of Internet Explorer. And you might be wondering, like, how are they not getting sued like out their butt at this particular point? So what Windows did was they made Internet Explorer free. They put it on all of their Windows 95 stuff, and because they make it free, you can't sue because they're not making any money off of it. So they don't have to pay royalty fees. They don't have to like do any like non-competing clauses or anything like that because it's completely free. They're not making any money off of it. Even though Netscape is better, Internet Explorer is free. So you kind of have to balance that thing where it's like, do I want to pay $50 or do I want to have something free? It's like, it's really your call. And because of that, we have like the official beginning of the internet market share. And this battle kind of continues today. It's no longer Internet Explorer and Netscape, but you have Firefox and Chrome, even though Chrome is the clear winner most of the time. You have Opera and Safari and a bunch of other smaller browsers. Somebody's going to come along soon, and they're going to challenge Chrome. Like it's just history will repeat itself. Somebody will challenge Chrome at one point. Nobody thought AOL could be challenged. No one thought Internet Explorer could be challenged. And yet, where are they today? They're nowhere. So fast forward a year, like 1995 was a big year. We're going to fast forward to 1996. CSS was created in 1996. So HTML comes out first and CSS comes second. And up to this point, people had to actually put the code into the HTML itself, which means it's not reusable if you wanted any sort of style. And CSS helped people reuse the styles they had already written. Internet Explorer 3.0 comes out a little later that year. Netscape Navigator comes out a little bit faster. At this point, Netscape has 90% of the market share and Internet Explorer has 10%. But Netscape is paid and Internet Explorer is free. Internet Explorer has the same features as Netscape, but also has things like supporting CSS and has ActiveX, which allows for things like C++ being put into the web page, not just Java. Internet Explorer also, like, they wanted to create new tags and not wait for the W3C. They're like, people want this now. I want to do it as fast as possible. Netscape was like, let's wait for the W3C. Let's wait for the W3C. And that's why you'd see a lot of things like this on web pages from way back when. Remember, like, best viewed with Microsoft Internet Explorer. You might want to get Netscape Now 3.0. Basically, what happens is these logos generally recognize the divergence between the standards supported by the browsers, which signified which browser was used for testing the pages. So Netscape's really skeptical about style sheets. They're really skeptical about going outside of the W3C. They want to do everything by the book up to this point. And Microsoft's kind of being like, we're not charging any money. Let's just go with anything that's going on. Eventually, what happened was goodbye, Netscape. Netscape would live for a few more years afterwards, but Microsoft had pretty much cut off its air supply because it's providing a pre-installed free browser that's basically just as good. It's kept up with the times. So let this be a lesson to like everybody whenever you're going into like any sort of business. If you're not keeping up with the times, like you're going to go out of business. So if you're using very old technology, if you're not keeping up to date, like you're just going to get steamrolled. You can kind of see like this was in the course of like 2 years with Netscape. There was a CSS like standard that came into play. They were supporting more backend languages, and Netscape was like, no. They kept saying no to everything, and because of that, they're no longer around. Similarly, it's Internet Explorer versus Chrome now. Internet Explorer doesn't support as many things as Chrome does, and now you can kind of see a repeat of that happening. So while like Netscape is dead and you can't really use it anymore, it gave birth to things like HTTPS, JavaScript, SSL, which is the thing behind HTTPS, Java plugins, Flash plugins, everything like that. It all came from Netscape. This was like kind of like the grandfather to all of the modern web. It's going to be to be continued. We're going to see what happens in the future with our browsers and our operating systems. I'm not going to take a break at this point because we have no time. All right, let's keep going. That was a little bit of the history of the browsers. Main big takeaways was mid-90s, lots of things going on, keep up with the times, and JavaScript was written in 10 days. So let's talk about JavaScript. The formal definition of JavaScript is that it's a single-threaded, non-blocking, asynchronous concurrent language, which means literally nothing to anybody else. So let's break it down into what I consider to be like important things. So number one, JavaScript is arguably, no, it's not arguably, it is the most popular programming language on the market today. Like you can check GitHub, you can check a bunch of other different websites that are out there. It is the most popular programming language, and it's the one that people want you to know and the one that people want in the future. It's 23 years old, and it runs within a browser runtime, and it runs within a system runtime. The system runtime is a little bit more recent. It's like Node.js, and it's maintained by this thing called TC39, which is a group within Ecmo International. Everybody still reports all the way up to W3C, but this is the particular group. The TC39 is the group that maintains all of the JavaScript standards. It costs $3,000 a year to join it, but you can kind of see how the sausage is made underneath the hood. So if somebody will propose something, like they said, var is bad, maybe we want to use something like let and const, and then they will back it up and people will vote on it, and you can see like people saying yes or people saying no. And there's 4 major JavaScript engines that back most of the things that we use today. So Google has a JavaScript engine on their end called V8. Apple, for their Safari browser, has something called WebKit. Microsoft has something called Chakra, which for their Firefox, and Mozilla has SpiderMonkey for their, this is Internet Explorer, this is Firefox, sorry. So yeah, Brendan Eich like no longer maintains it by himself, but instead runs this particular group, and he still is a major player today, even though he's a decamillionaire and probably doesn't need to work ever. So when we go back to our huge, disgusting thing, it says a single-threaded, non-blocking, asynchronous concurrent language. Let's break it down term by term. So we start off with single-threaded. Single-threaded means that one thing happens at a time. So when we go line by line here, like var a number equals 42, var a string equals hello world, it's only executing one thing at a time. So line 1 is going to execute, then line 2, then line 3, then line 4, and it's only going to execute one line at one time. That's what it means by it's a single-threaded language. When we take a look over here, let's see if I can click on this. So let's run this. So when I run this particular bit of code, this is kind of like a visualization of what's happening. I don't know if you can see it terribly well, but essentially what's happening here is it's assigning all of these different variables, and then it's only executing one thing at one time. Oh, goodness. So on the left side here, you have something called the heap. Heaps store variables. It's basically your memory management. When you define a variable, it's stored inside of this heap. So when I define a number, a string, an array, a function, all of that stuff is stored inside of this heap here. On the other hand, on the other side over here, you have what's called a call stack. The call stack is what happens when you are actually calling functions or when you're calling variables. When one function call finishes, it gets removed from the call stack and then moves on to the next one. Some other things that we should keep track of when we move into today's stuff is this concept of web APIs. This is extra stuff that your window inside of your browser exposes to JavaScript. And an example is the DOM. We did this in week 5. It gives JavaScript the ability to modify HTML code that's actually on the page. There's also XML fetch and request, which is like the API that we use to make web requests in the background. There's many more, and I'm going to send these slides out for you to kind of take a look at. But there's also other things. There's, based on like if I type a key on the keyboard, if I click around, if I scroll, if I move my mouse or something like that, at that point, the web API comes alive and does something to my particular my particular browser. Inside of JavaScript, it handles two different types of calls. It handles synchronous calls and asynchronous calls. So synchronous calls is the one that we're going to start with. These are calls that execute immediately, right away. So if we take a look at this particular bit of code, window.document.innerHTML equals hello world, if I were to copy and paste this into my browser, what would I get? Hello world somewhere inside of my browser. The code that we've written so far in Rails is mostly synchronous codes that executes immediately. The exception of this is jobs, which we talked about a couple weeks back, which was I'm going to execute something right now, but in the background, I'm going to actually do your particular code. On the other hand, we have synchronous means it happens right now. Async means I'm going to execute something right away and respond at some point in the future. It's kind of like jQuery's Ajax. Like I'm going to, when you submit a form, like I say, good to go, and then you can continue on with your day. Who knows what's happening in the back end? Maybe I'm, sending a message to my department of, my ordering department, my shipping department. All these things are happening in the background, but you get notified right away. So if you take a look at this particular bit of JavaScript code, we have window set timeout function with console log of hello world that times out after 1,000 milliseconds, which is 1 second. So basically, this is saying like after 1 second, you're going to console log hello world. This is basically asynchronous. It doesn't happen right away, but it's going to happen at some time in the future. All right. So now let's get into like more like React-ish kind of stuff. So in Ruby, we had Ruby Gems. It was an online library that brought third-party libraries into my code. Inside of NPM, it's the same thing as Ruby Gems. It's just one central location for all of your particular like node libraries that you may or may not need. So it's a lot nicer looking than Ruby Gems because who knows? Who knows? Oh, this looks a lot nicer now. All right, so NPM, there's no shortage of things that you can do. Some popular ones that you're probably going to use are like HTTP server. So they have like a zero configuration HTTP server. And this looks very similar to, let's say, like Binding Pry or something like that. So on over here, they tell you like this is how I'm going to install this particular like node package or a library / Ruby gem, and it gives you a little bit of a description. You can kind of see like this, it's a simple zero configuration command line HTTP server. It's good enough for production usage, et cetera, et cetera. Someone wrote this particular library for you. It's stored here on npmjs.com. You can kind of see all of the continuous integrations. So you can kind of click on this. You can kind of see that Travis CI continuous integration is basically saying like, I'm keeping track of all the tests. All the tests are passing. This was 2 months ago was the last time that this particular thing was updated, but it is passing all of the tests. On the right-hand side here, there's a collaborators list, and you can kind of see all the statistics that are going on. So you can see 8,000 people downloaded this in the last day. There's 122,000 in the last week, almost 500,000 in the last month. So this is a well-maintained. People use this particular this node package. They'll tell you a little about how do I install it, how do I use it. Here's all the options that are here, and then you can even jump onto the GitHub page for more information. All of the libraries that you're going to need are going to live here on NPM. So NPM library is the same thing as a Ruby gem, exactly the same thing. Yeah, so NPM, they call themselves the JavaScript package and dependency manager. It's a company that's based out of Oakland. They basically just are a phone book of all the different node packages that you may or may not need. Node and NPM comes pre-packaged with Node, And Node.js can be installed directly or managed using what's called the Node Version Manager. We actually did this on the first day, so you don't have to worry about this. Node is completely set up on your machine. You don't need to set anything up because we did it on the first day. So you're going to be using npm starting today. Whenever you want to bring in Node, you're going to run this particular command, npm init. So kind of like git init when you wanted to initialize a new Git repository. If anything has the ability to be a Node, like to be managed by Node, anything has the ability to be a Git repository. So all you have to do is go inside of your particular repo that you're working with and just type in npm init. And it's going to run through this kind of this wizard more or less of like, what would you like me to like test out for you? It's going to prompt you for all the things that you're going to need for the project. And in the end, it's going to create what's called a package.json file. This package.json is a file that creates all the dependencies and all the configuration setups that you're going to need for your particular Node application. And we're going to run through this probably this afternoon. If you look inside your package.json file, it has most of the stuff that you entered a little bit earlier, but the main thing you need to know is this scripts area. This is a bunch of scripts that you can run against your application. So you would run this using npm run test, npm run hello. It's the same thing as rake or Rails inside of Ruby on Rails. So like you did Rails DB drop, Rails DB migrate. Those were things that Rails knew how to do. Similarly, you have npm run hello, npm run test. The scripts though that you're going to be using will exist within this particular scripts tag right here. Let's keep going. All right. So ESLint is another tool that you're going to be using quite often. It's a static tool that basically checks your code and makes sure that it's up to standards. It's similar to Ruby's Rubocop. So if you remember, when we run Rubocop against our code, it reads every line of code, says, does it adhere to my standards? Does it adhere to highest standard? And what's wrong with it if it does not? Similarly, ESLint will also check, does the JavaScript code that you're writing live up to the standards that we need to have? ESLint in general helps you write better code, helps your team write consistent code, because it's kind of like, oh, if Janet is coming from ES4 and we're writing in ES7, like all of her stuff is outdated because she has ESLint, this is automatically going to go through and check all of her code. Hey, Janet, you're not supposed to be using var, you're supposed to be using let or const or something like that. And in general, it's just going to reduce the number of bugs that you do have. It looks a little something like this. So if you were to run ESLint against a specific file, it would show you line 2 at space number 5. So somewhere on line 2, files is defined but never used, formatter is defined but never used, CLI engine is not defined. Like it'll read through everything and make sure that the code that you write is as close to perfect as possible. You kind of see, so you have the line number and the space number, the error, the thing that's actually wrong with it, and at the very end here, you have the rule that's being violated. You can find all of these rules over here at eslint.org. You can kind of see, like, let's take a look at some of the rules. So there's one that's really annoying called no comma dangle that I really hate. Dangle. Basically, they say that you must have an extra comma at the end of a list, even if you don't have something after it. That's one of the rules that ESLint has said, like, you must have. But you can also turn these rules off if you'd like. So I always turn off comma dangle because I think it's stupid.
Will your program still compile with errors?
What's that?
Will it compile with these red errors?
That's a great question. So Aaron's question was, will your file compile if you have all these errors? It will if it can. Some of the things like, so this one says files is defined but never used. This thing defined but never used probably won't blow up everything. This says indentation of one character, not defined, unexpected console. So based on these particular errors, I believe it will still run. But if anything does blow up, you can immediately just run ESLint on it and you can see exactly what line is breaking and what you can do to fix it. All these errors here, I think would still render something out on the page. So this is an example file that's generated when ESLint comes into your code base, similar to like Atom and Sublime's like rules. These are the things that you want to tell ESLint what to enforce. So you see that comma dangle is 0, which means true. I can turn it to false by just turning it on to 1. So we talked about ESLint. Now the other thing that we're going to be working with today is something called Mocha. Mocha is similar to RSpec. It covers unit tests all the way up to end-to-end testing. So what this means is that the new features that you add will behave the way that you expect when users do stuff with that thing on the page. Oftentimes when you're talking about writing tests, it captures a lot of business requirements. So it's kind of like, when I hit submit on this form, it will notify shipping department, right? Or it will send an email out in the future. And the main thing to know about tests is it makes your manager happy. There are different types of tests. The main bunch are going to be called unit tests. These are the very, very large block of tests that are at the bottom. It's basically, I'm going to test the methods that I write, the classes that I write, mostly in isolation. Then I have something called functional tests. Let me preface this by saying, most of the time you're going to be writing unit tests. So you're going to be introducing new classes of code, new functions and things like that. You need to test those to make sure that they do what they expect. But at a larger scale, you have functional tests and scenario tests. So functional tests and scenario tests, basically what they do is say, now that you've added this code inside of here, how does it affect the rest of the app? And generally speaking, the scenario test and the functional test will be a QA team's responsibility. Your job is whatever code that you write, you have to write unit tests to back it up. And this is what Mocha tests look like. It's pretty similar to RSpec, you know? So we have describe something. I'm not positive on what this does, but it looks like describe answers reducer. It looks like it takes in a function. After each, I'm going to clean. So this is probably a database cleaner. So I'm going to clean everything out. So it verifies an environment variable is set. Expect environment to be okay. It does blah. It does blah. Like the reason why we taught RSpec is it's very, very easily transferable over into Mocha. These two look very similar. Expect environment to be okay. You know, it looks like the only difference would be like to_b and then space okay. You know, like this is just to.b.okay. And then we talked about ES Next and Babel. So ES stands for ECMAScript. It's the formal name for JavaScript. And basically what happens is your browser will update their JavaScript engines. Remember, Google has V8, Mozilla has SpiderMonkey, Internet Explorer has Chakra or something like that. Your browsers are going to update their JavaScript based on their own schedules and their ever-changing patch numbers. What happens if you have a browser that's super old and has super old JavaScript built in? If you're writing stuff in ES6, how is that going to operate for the grandmother and grandfather in, you know, rural America with Internet Explorer 1.0 or 2.0? So that's where Babel comes into play. Babel is a transpiler, which means that it takes your code and translates it into code that can be, it's forward compatible and backward compatible.
It seems crazy that it's forward compatible when the forward is unknown. I can see it being backward compatible because you know what it is, but how can it be forward compatible if you don't even like?
Yeah, that's a great question. So the question was, backward compatibility makes sense because if we're on ES7, then ES7 means that, you know, we can go back to ES4 and 5 because we know the standards at that particular point, right? So what happens if I'm writing like ES4? Wait, the question was like, why would you go forward?
You don't have to answer. I'm sure it's just that's crazy.
Oh, I mean, it's just kind of like if I'm writing an ES6 and the current thing is ES8, then I already know what the standards are for ES8 are. So I can just translate from ES6 to ES8 pretty easily. Yeah. ESNext just means whatever the next version is. So yeah, ES stands for Ecmo Script. It's the formal name. ES6 is the version that we're using right now. It's the biggest rewrite. Babel will forwards and backwards compile it so that you can so it can be used on everyone's browser. You don't need to worry about setting up Babel because this setup takes forever. We're going to be using a generator called Create React App, and that's going to do everything for you. So you don't have to worry about forwards compatibility or backwards compatibility. It'll be built in for us. So ES6 has brought in a lot of big changes, and I just want to go over some of them before we kind of wrap up here and get ready to go. The first thing is let and const. Let and const are the successors to the old var. And what that means, what it does is it's block scoped. So basically that means if you have a variable that's defined within one individual block, it's only available within that one individual block. Let is something that can change, const is something that cannot. So let's take a look at some code back and forth to see what the differences are. So when you use constants, make sure you're using all uppercase letters like this. So when we use, the convention is to use all uppercase so that you know it's constant. It's going to stay the same like this. So let's say I want to say my favorite number is constant and give it to the value of 7. So I have to do const my fav equals 7. This is stuff that we've done already. And when we try to overwrite it and we do my fav equals 20, it's going to throw an error because once you define a constant, you can't overwrite it. It's something that's going to be, that's why they call it a constant. This is block scoping using var and then using let. So using let, variables are only available within its immediate scope. So let's take a look at the var test. So on line 2, we have var x equals 1. If true, which is always going to evaluate to true, x equals 2, console log 2, console log x, and then console log x again. So before, variables were not block scoped, meaning that once you define it, you can alter it within lower level blocks. So you can kind of see I've defined var x here on line 2, and then between lines 3 and 6, I've redefined var x. This is actually supposed to be another x, but I'm actually overwriting the original. So I'm actually altering this same variable within this first before we were using let and const. On the second block here, we're using a function called let test. So here we have x equals 1, and then over here we have x equals 2. When we console log the x again, the x actually only exists between 12 and 15. This original x is not touched at all. So yeah, that is one example of why let is a little bit better than var. We're scoping it just to its immediate block. So this x, even though it's named the same thing as line 11 here, it only exists between 12 and 15. So there's a lot of benefits to having let and const like this. The number one thing is it's more semantic. We know what can change. We know what's not going to change. Before it was just var everything. That was like the worst thing because you don't know what's going to change. You don't know what's going to stay the same. So let, kind of like Ruby has class variables, constants, and local variables and instance variables. You know the things that are going to change, and you know the things that are not going to change. If I have a local variable inside of a method, it's not going to be available in another method unless I make it an instance variable. And ES6 caught up to that. So let and const, you know what's going to change, you know what's not going to change. And with block scoping, you know exactly where the variables are going to be used. Like before, you would just overwrite them in different areas, and you'd have to basically chase down where you overwrote it by accident. The other big thing when it comes to ES6 is something called fat arrow functions, or arrow functions for short. The main two things you need to know is it allows for shorter code, and it automatically binds this. Now, this keyword in JavaScript is the most painful thing that I've had to deal with in a long time. But I'll try to make it as painless as possible. So in ES3 to 5, let's say that we have this function called person. This is actually a class. Let's go back. So if I wanted to, using let and const, without using let and const, I had to use var. So if I wanted to scope the context of person, I would have to usually do something called var that equals this. And you can already see like var that equals this makes absolutely no sense. So we have, in this example, this is scoped to line 3, the person. If we were to call line 6, like with this, this refers to the grow up function and not the actual person. So oftentimes we have to set, back in ES 3 to 5, you have to set var that to this on line 3, so you still have access to that in line 6. I just lost everyone, and that's exactly why they decided to change this. So it's kind of like, I'll use this analogy over and over again. But it's like saying, let's say you're a frequenter at a nightclub, and you're at the VIP section. Now, while you're at the VIP section, you can do many things that people on the bottom floors cannot do. So let's say you're on the top floor, you're on the VIP section. You can order fancy food. You can order fancy drinks. Those are things that you as a VIP have access to because you're a VIP. They know that you're a VIP because you're within that VIP area. Let's say then you want to go down to the main floor and you want to hang out with the regular plebeians like myself. I will be down there on the main floor. And you say, I want to drink fancy food. I want to drink fancy wine and eat fancy things. At this particular point, the context that you're in no longer applies. Like, you're not allowed to drink fancy wine and eat fancy food because you're within the context of the main floor. But if you get the little stamp on the way out, your context is bound back up to that upper level. And this will make more sense as we start seeing it in real life. So just main purpose of this, just look at line 3, see how much that one sucks, and then we're going to jump over into this next one. This is ES6 using the fat arrow functions. So when we have this.age equals 0, this is automatically bound to person. And then when we do set interval here, this, like, because we're using this fat arrow function, automatically binds the context back up to this person instead of this set interval inside of here. The other big thing inside of ES6 was the concept of classes. So up to this point, like, JavaScript didn't really have reusable classes ever. It wasn't very object-oriented. It was more functional. And ES6 decided to bring in some more classes for other language developers to more easily read. ES 3 to 5 looked a little something like this. So if I wanted to create a new person, I'd create a function called person that took in a name. This dot name equals name, so like basically at name equals name. This dot say hello equals function, and hi, my name is whatever. So if I wanted to create a person, I'd do var Andy equals new person with Andy. And if I called Andy.say hello, it would call this function, which would output hi, my name is Andy. So this is what like old object-oriented code inside of JavaScript used to look like. But when we take a look now, this is ES6. It looks much more similar to Ruby, much more similar to Python. So we have class person before we had function person. And we have a constructor. The constructor is the same thing as initialize. Constructor takes in a name, and then we do this dot name equals name. So at name equals name. Then we have other functions. So def say hello is now just say hello, takes in no parameters, and then it has the curly braces. This is the code that's being executed. Console log, hi, my name is Andy. So I have var Andy, which should probably say let Andy, or const Andy, new person Andy, and then Andy say hello. So you can kind of see this is a little bit more foreign to you guys because you haven't done a lot of JavaScript in a while, and this is pretty foreign looking. And this is much more friendly looking. I can just translate constructor into initialize, and I can put a def in front of this and just know pretty much what's going on. We talked about this. All right, let me stop recording here, and I'll go over what we've got for this afternoon.